Okay, hi guys. So this is the last topic of our series of video lectures on JEE syllabus, specifically organic chemistry. Okay, so let's get started. So the last topic is hydrocarbons. So we'll be seeing this. This is majorly a summary of what we have studied so far. Okay, and with some informations which we have not discussed. Okay, so obviously this can be classified into either saturated or unsaturated. Okay. Saturated, obviously we know that those are alkanes, and those are also called paraffins. Okay, in unsaturated, again we can subdivide it into two parts, which is alkenes and alkynes. Alkenes are obviously called olefins. Okay, now if we talk about the thermodynamic stability of the three, the order is alkane, then alkene, then alkynes. Okay, next let us talk about the chlorination of methane. Okay, this is chlorination. Chlorination of methane. In this, we have a methane molecule. If we are passing Cl2 in presence of H nu, then we get formed CS3Cl plus HCl. Okay, next if we look into the mechanism of the same, we get first is chain initiation, which is nothing but if we pass Cl2 molecule in H nu, we get free radical Cl. Okay, then next is chain propagation, in which if we have something like a Cl dot, which will actually attack on one of the H from CS3, and this is the RDS, and as a result we will be getting HCl plus CS3 dot. Okay, and this CS3 dot actually reacts with more of Cl2, and we get form CS3Cl plus Cl dot. Okay, and finally the third step is chain termination. So this is obviously we have two CS3 dots can actually form to become ethane. Okay, or two Cl dots can actually terminate to become Cl2, or if one of the Cl dot reacts with another CS3 dot, we can get CS3Cl also. Okay, so what actually this was the mechanism, and now let's see some more example on the same. If we have a methane molecule, okay, and if we react it with Cl2 H nu in excess, I mean excess Cl2, so what would happen is first we'll get CS3Cl, then next on this CS3Cl, one more Cl will get attached. Next on this compound we'll get again CHCl3, and on this we will get CCl4. Okay, plus HCl you can form sideways. So let's discuss the characteristics of this reaction. Okay, so characteristics. That would be something like, first we have that formation of free radical is the redetermining step. Formation of free radical is the RDS. Okay, second point is that if chain initiation is the RDS, then I2 is most reactive. Okay, if chain initiation is the RDS, then I2 is most reactive. Okay, third point is that to maximize the yield of the reaction, methane is added in excess. Methane is added in excess. Okay, next is that if Cl2 is added in excess, following product will obtain. So what happens if Cl2 is added in excess? The following products will be formed, which we have already discussed. Okay, next we have a question that you have to find the monochloro products which are formed. Find total number of monochloro products. Okay, so let's start. First example we have of this. Okay, we pass it in Cl2HNO. Okay, so what products can we get? Monochloro, Cl, we can have a free radical here or we can have a free radical here. Okay, so let's say if I have a free radical here, we'll get something like this compound, and if we get free radical here, we get something like CH, Cl and CH3. So obviously it will have two products. Why? Because it would form enantiomers. Okay, so we'll have R2 and S2, chloro, and what is this, butane, similarly like this. So total 3 products are formed in this case. Okay, so one molecular product here and 2 here, one is enantiomer. Okay, let's see second example, where we have total number of monochloral products in this case would be, when passing to CS2 and Cl2 and HNO, obviously 1 here, 2 here, 3 here, and then 4th here. Okay, here or here it would result in the same compound. Okay, so total number of 1 2 3 4 5 5 is the total number we'll get here. Okay, so so I think we can get one more here. Why? Because these two would be different in configuration. So I'll tell you why. So let's suppose it acts on this carbon atom and it is going above the plane, so we'll have CH2Cl, and this would be going below the plane, CH3 here, H and this chain here. So this would be one of the compound, and another compound, if it would be that if this Cl attacks this carbon atom, then we would have something like CH2Cl here and CH2Cl here, CH3 here, rather. Okay, this H here and the chain goes here. Okay, and these two compounds are different. Okay, in one case CH2Cl is coming out of the plane, and in another case CH2Cl is going below the plane. Okay, these two would be mirror images of each other. These two would be enantiomers. So total number of answers, total number of molecular products would be 6. Okay, so we found 2 enantiomers. This is one of them, and another at this carbon atom. Okay, so we can get that we get 4 2 enantiomers. So 2 into 2 is 4, and 5 and 6 here. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the same, and then we'll be seeing reactivity selectivity principle. With this, good luck and goodbye.